Okay, so now that you know the molecule is covalent, how do you know what it should look like? Like, what should we draw? Well, maybe, how do we know what each of the diatomics should look like? So remember the Hobrowinkels? Got two more to add to this. As some guidance, atoms will typically form the same number of bonds as they have unpaired electrons. That can be determined by group number. Pause that, go back, have a look. You may want to write it down. I'm going to draw some of these. So I'm going to draw H2, Br2, F2, I2, and Cl2 to start. Alright, so I would draw each pair. I would show each had 7 valence electrons, with the exception of hydrogen, of course. And I'm going to circle the single electrons. Alright, demonstrating the formation of a covalent bond, or at least how we would represent a covalent bond. Alright, so hopefully you've seen all of these in grade 10, and that's not something new. Typically we trade the loops for lines, alright, just to clean up the diagrams. Remember, each line in one of these pictures represents 2 electrons. So now, these were in group 17. Group 17, each is supposed to make 1 covalent bond. All the atoms shown are now sharing to get 8 valence electrons. So now, what about oxygen and nitrogen in that Hobrowinkle series? Well, let's have a look at oxygen. 2 oxygen atoms would each have 6 valence electrons. Well, make your appropriate pairs. Now, each oxygen has shared in order to get 8 valence electrons. Alright, so there should be 2 lines between the oxygens. Try nitrogen, N2. So I'm going to draw 1, 2, 3 sets of loops between the nitrogen atoms. This would result in me trading those loops for 3 lines. Right, but again, in each case, each line represents 2 electrons. All the atoms present have 8 electrons. Now, in order to count this up, I'm going to say, so there's 2 electrons there in the lone pair, 4 more with 1 bond, 4 more, 2, 4, 6, 8 electrons around each of the nitrogens. Okay, is how we would count these up. So, group 16 is supposed to make 2 bonds. Oxygen's in group 16 and did. Nitrogen's in group 15, and by my little diagram here is supposed to make 3 covalent bonds. It did as well. So now what's with S8 and P4? 2 more exceptions, or 2 more to add to that Hobrowinkle series. I'm going to tell you that sulfur exists as what's called an octatomic. So there are 8 sulfur atoms in elemental sulfur. Draw 8 sulfur atoms. Alright, so I'm going to go and I'm going to put all of my electrons in. Now, make your pairs. Right. So you're going to see this forms an octagon. Now, being able to reproduce sulfurate, I'm not overly concerned if you have that committed to memory. But again, you can see each sulfur made 2 bonds. Sulfur's in group 16, sits right below oxygen. Supposed to make 2 bonds. It does. Okay, phosphorus is a tricky one. Phosphorus exists in what's known as a tetrahedral geometry. Right, each phosphorus is going to make 3 covalent bonds. Let's try to draw these. Hopefully this is also some evidence for why we get out, where I'm going to get you out of drawing these loops between the atoms. Right, this is incredibly messy, hard to see. Alright, so yeah, pretty gross. Let's trade this for lines. Even with lines, this is a tough one to see. Right, so trade all my loops for lines. Right, I forgot to loop a pair of electrons up on the top diagram. Right, again, in each case, phosphorus is group 15. Group 15 should make 3 covalent bonds. Each phosphorus atom does make 3 covalent bonds. So this other term up the top here, bond order. This is basically the number of bonds between 2 atoms, and this is just some helpful vocabulary. Alright, I'm going to look at a few molecules here. So Cl2 you've seen, so this is the Lewis structure for Cl2. I'm going to say there's a bond order of 1, and I would refer to this with the verbiage a single bond. Oxygen, you've seen, has 2 bonds between the oxygen atoms. I'm going to say this has a bond order of 2, and the terms I'm going to use, double bond. Nitrogen, N2, has 3 bonds between the 2 nitrogen atoms, so it's a bond order of 3, and I'm going to say that this has a triple bond. Right, phosphorus, right, with its convoluted structure, all right, is actually filled with single bonds. All right, so between any of the 2 phosphorus atoms, there's only a bond order of 1, and it's all single bonds. So bottom line, you need to draw the structures to figure out single, double, triple bonding.